Here we come to the A-Level Physics 2009 structure question 2. We have a skier ski down from a platform which is 30 meters above this level, and the skier is projected at a speed of 21 meters per second at an angle 10 degrees below the horizontal. So firstly, part 1, we are going to find the work done against friction. We can consider the conservation of energy. Originally, we have PE when the skier is at this point. When the skier goes down, PE change to KE. So in this section, PE change to KE. But not all PE is changed to KE. Some of the energy may be lost. And so here, when it comes down to the lowest point of the platform, the skier would only have KE. So we can write down an equation. The PE at the top will become the KE at the bottom plus some energy loss. So mgh equals half mv squared plus energy loss. And then we are going to put in the numbers. M is 84, G is 10, H is 30, half mv squared. Solving this, the energy loss will be 6678 joule, which is equals to the work done against friction. So part two we focus at the motion after the skier leaves the platform. So it is like a projectile motion. With a projectile that is project at a speed of 21 meters per second at an angle of 10 degrees below the horizon. So I would like to calculate the time of flight for the skier to go from here to here. This is the starting point, this is the finishing point. At the starting point, I would like to resolve the velocity into its horizontal component, 21 cosine 10 degrees, and its vertical part, 21 sine 10 degrees. So we know that the skier would land after going a horizontal distance of 60 meters. So we have Sx, we have Ux, and so we can make use of these two data and try to calculate the time of flight. So we consider the horizontal part of motion. We have Sx equals Ux t. Put in the numbers. Sx is 60, Ux is 21 cosine 10 degrees. Time of flight. The time of flight will be 2.901 seconds. So the skier will land at 2.901 seconds with the moment when the skier leaves the platform taken as 0. Next part 3. we would like to find the magnitude and direction of the skier's velocity at landing. So we would like to find the skier's velocity at this point. We would like to find v. Again, we can try to resolve the v into its horizontal component vx and the vertical component vy. Don't forget that vx and ux should be the same because horizontal part is a uniform motion. So vx is also equals to 21 cosine 10 degree. Whereas for the vy, we have to do the calculation using the equations of motion. With uy equals 21 sine 10 degree, okay, we can use vy equals uy plus ayt, considering the vertical projectile motion. So put in the numbers, 21 sine 10 degree. I put a negative sign because it is going downward originally. Downward, so negative. Plus negative 9.81. G is 10. So negative 10 times the time, 2.901. So Vy would be negative 21 sine 10 minus 10 times negative 32.66 meter per second. And for the horizontal part, Vx equals Ux, which is equals to 21 cosine 10 degree. So it's 20.68 meter per second. So the skier is moving in this way. This is the skier. Horizontally, it moves with 20.68 meter per second. Vertically, it moves with 32.66 meter per second downwards. And we are going to combine the two together to find the resultant V. So the magnitude of the resultant V is given by Vx squared plus Vy squared taking square root. So it's 20.68. 32.66. .6 meter per second. This is the magnitude of V. However, the question asks us to find the angle instead. Okay, so we would like to know what is the angle to the horizontal. I would like to know the angle to the horizontal. So the angle to the horizontal, that means this angle, I call it theta. Theta can be calculated using the expression tangent theta is equals to Vy over Vx, which is 32.66 over 20.68. So theta is equals to 57.66 degree. Okay. However, it is said that the blue one is angle theta. It is said that the ramp for landing is having an angle phi, and phi and theta can have at most 5-degree difference, which is set here. And the slope, the velocity and the slope should differ by no more than 5 degrees. Now we know that theta is 57.7 degrees. So we can calculate the angle phi by doing subtraction. So angle phi would be at most equals to theta minus 5 degrees, not more than 5 degrees lah, at most. Maximum tolerance is 57.7 degrees minus 5 degrees, so it will be 52.7 degrees. So that's how we get the angle of inclination phi of the slope.